Welcome to Wisdom Outlined Coaching. My name is Askar Khan, your math coach. Our mission is helping you learn. In this lesson, we will express rational numbers which are in decimal form and change them to fractions. How do we do that? Let's dive into the lesson. In our previous video, in lesson number 2, we studied the decimal representation of rational numbers. For those of you all who want to know in detail the decimal representations, please watch lesson 2 of number systems. Let's now reiterate what we studied before. The first point, the decimal representation of a rational number is either terminating, meaning it stops after few digits. For example, look at this, 0.5. Is this a rational number? Yes, because the decimal is terminating. It is stopping after one digit. 2.356. Is this a rational number? Yes, because the decimal is terminating after 3 digits. Okay, 0.9562. Is this a rational number? Yes, because the decimal representation, the decimal is terminating after 4 digits. So, 1 point is a rational number in its decimal form will have a terminating decimal. Okay, what is the second point? A rational number in decimal form will be non-terminating but repeating. Non-terminating but repeating digits. We will see how it is. For example, 0.3333 on and on and on, which can be written as 0.3 bar. Is this a rational number? Yes. Why? Because the decimal is non-terminating. It is going on and on and on, but it has a repeating digit, 3. And when we put a bar over the digit, it means that that digit is repeating. Okay, what about this? 0.27 bar. Is this a rational number? Yes. Why? Because it is non-terminating but repeating. This is nothing but 0.27, 27, 27 and so on. So do you understand? Once again, in detail, we have it in video lesson number 2. Please share and also review that lesson. So decimal representation number 1, it's terminating, or it could be non-terminating but repeating digits. Now we will see how to change these decimals as fractions. How do we change them into fractions? We will see that now. Now let us look at how to change decimals to fractions. For example, let's take a decimal number 0.5. Is this a rational number? Yes, because the decimal is a terminating decimal. Therefore, it is a rational number. If it is a rational number, then it can be written as a fraction. Fine. How do we write this as a fraction? Let us see. Because it is a terminating decimal, we will write it something like this, 0.5 over 1. It is same as 0.5. Now in our lower grades, we have learned how to shift the decimal points. Can I shift the decimal point one digit to my right? And when I do that, because I shifted the decimal point one digit to my right, I will put 10 in the denominator. Now my number is 5/10. Is this a fraction? Yes. So we have represented a decimal number as a fraction. But wait a minute. Can this fraction be simplified? In other words, is there a number that can divide both these numbers? Which number can divide both these numbers? 5. So I can divide the numerator by 5, denominator by 5. So what do we get? 5 divided by 5 is 1. 10 divided by 5 is 2. So the decimal representation of 0.5 is nothing but 1/2. Now do you notice how we change a terminating decimal into a fraction? Let us take another example. 6.24. Is this a rational number? Yes. Why? Because the decimal is a terminating decimal. So if it is a rational number, it can be written as a fraction. Because it is a terminating decimal, can I write this as 6.24/1? Okay, let's shift the decimal point. Let us shift the decimal point 2 digits to the right. And because I am shifting 2 digits to the right, I will put 2 zeros at the denominator. So we have studied about the details of shifting the decimal points, why it is zeros added to the denominator in our lower grades. So we are not getting into those. So now our fraction is 624/100. Right? So 6.24 can be represented as a fraction. But observe, is there a number that can divide both these numbers? Think. This process of dividing by a common number is called simplification of the fractions. We will get into detail when we take up fraction lessons. So stay tuned, subscribe to my channel, and do keep sharing the videos with your friends. Now, a number that can divide both these numbers, 2. So let us divide by 2 and divide by 2. Now observe very carefully the division that I am doing. 624 divided by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. 4 divided by 2 is 2. And 100 divided by 2 is 50. So our new fraction is 312/50. Okay, let's push the same question again. Is there a number that can divide both these numbers? Yes, 2 again. So we will divide this by 2. Divide by 2, divide by 2. So what do we get? Observe again. 3 divided by 2. 2 1 times is 2. 1 is remaining. I give it to the next digit. It has become 11. 2 5 times is 10. 1 is remaining. I give it to the 2. It has become 12. 2 6 times is 12. So 312 divided by 2 is 156. And of course 50 divided by 2 is 25. So the decimal representation of 6.24 can be written as 156 over 25. Is there a number that can divide both these numbers? No. So we say that this fraction is in the most simplified form, although it is an improper fraction. Don't worry about that. So now you get an idea of how you represent a terminating decimal into a fraction. Now let us see how we change a non-terminating but repeating decimal into a fraction. Okay, now let's try to understand how to change a non-terminating but repeating decimal into a fraction. Don't worry about the example number. What is this 7? Example 7. Don't worry about that. Just focus on the problem. In life, we will come across things which are important as well as unimportant things. Learn the art of focusing on what is only needed. Okay? So let us see now. Is 0.333, which is 0.3 bar, a rational number? Yes. Can we write that as a fraction? Okay, we can. So let us see the steps now. How to change a non-terminating but repeating decimal. Follow the steps. The steps remain the same no matter what the numbers are. So the first step, let x be equal to 0.3333 so on. Let us label this equation as 1. Okay? That is our first step. Our second step, because only one digit is repeating, I will multiply both sides of the equation with 10. If 2 digits were repeating, I will multiply both sides of the equation with 100. If 3 digits were repeating, we will multiply both sides of the equation with 1000. Good. You're getting smart after watching my videos. So now, since only one digit is repeating, we will multiply both sides of the equation with 10. So when x is multiplied with 10, it becomes 10x equal to, when 0.333 is multiplied with 10, you will shift the decimal point 1 digit to the right, it will become 3.333 so on. So let us label this equation as 2. Got the point? First step, let x be equal to 0.3333. Second step, because only one digit is repeating, we will multiply both sides with 10. Third step, subtract the first equation from the second equation. Okay? Now, in order to do this, let us rewrite the equations so that we can visualize them properly. One of the best ways of learning mathematics, visualize your steps. Each and every step, be able to see them. In this way, you'll be able to track your mistakes as well as see how you are proceeding in your working. So let us write the second equation first now. 10x is equal to 3.333 and on and on and on, minus the first equation, which is x equal to 0.333 and so on. Now we can subtract them. 10x minus x, 9x equal to. Now obviously 0.33, all this, if you minus with these decimals, they're going to get cancelled, isn't it? They're going to be zeros. 3 minus 0 is 3. So 9x is equal to 3. Got it? X is going to be equal to 3 over 9. Isn't it? We will study more about how to solve equations in our upcoming videos when we take up algebra of solving equations. For the time being, x you divide by 9, so x will be 3 by 9. Ask yourself the question, always the best way to learn and the best way to become a self-learner is pose questions to yourself and then try to come up with the answers. Is there a number that can divide both these numbers? Yes. Which number can divide 3 and 9? It is 3. So 3 1 times is 3. 3 3 times is 9. So now can you see? X is equal to 1 over 3. So 0.3 bar when represented as a fraction is 1 over 3. Understood the steps now? We will take up another example. The steps remain the same. The numbers may keep changing. Let's look at this problem. Show that 1.272727, which is 1.27 bar, because 27 is repeating itself. Show that it can be expressed in the form P over Q, where P and Q are integers and Q not equal to 0. First question. Remember, always question yourself, ask questions to yourself and come up with answers. In this way, you will become self-learners. Is 1.27 bar a rational number? Yes. Why? Because it is non-terminating but repeating decimal. And what are the steps of changing a non-terminating repeating decimal? We saw in our previous example. First step, let x be equal to 1.272727 on and on and on. Let that be equation 1. Isn't it? Okay. Now, because 2 digits are repeating, we will multiply both sides of the equation with 100. So, x times 100 is going to be 100x equal to. Now, if I have to multiply 1.2727 with 100, the decimal point shifts 2 digits to the right and it will become 1.27, it will be 127.2727 and on and on and on. Let us label this equation as 2. So remember those 2 steps? What is the third step? We did this in our previous slide. The third step, subtract equation 1 from equation 2. 2 minus 1. Let us visualize these 2 steps by writing them once again in the order in which we want to see. So second equation, let us write them down. Like 100x is equal to 127.2727 and so on, minus x is equal to 1.2727 and on and on and on. Now we can easily subtract 100x minus x is 99x is equal to 0.27, 0.27s. When you subtract them, they all will become zeros, isn't it? 127 minus 1 is 126. So 99x is equal to 126. X is equal to 126 divided by 99. Isn't it? Pose yourself the question, which number can divide both these? It will be 9. So observe how both these numbers can be divided by 9. 9 1 times is 9. How much is remaining? 3 is remaining. We give 3 to the 6. It has become 36. 9 4 times is 36. Divided by 99 divided by 9 is 11. So x is equal to 14 over 11. In other words, 1.27 bar, when it is represented as a fraction, is 14 over 11. Understood now how you change non-terminating but repeating decimal into fractions? Great. I hope you have enjoyed learning this lesson, and practice more, because practice will make you more proficient. And do share this video with your friends. Thank you for watching Wisdom Outlined Coaching lessons. My name is Askar Khan. If you want more math lessons and you're looking for a math coach, do contact me on WhatsApp in the number given in the description, below. Thank you. Subscribe to this channel and share it with others.